So, all we're doing here is talking about parallel vectors. So a very short extension on what we've been talking about. And as we know with lines, lines are parallel if they're going in the same direction. They don't necessarily have to have the same magnitude, it just means they have the same direction. Because vectors, a vector is something that has direction. So vectors are parallel, it means they're going in the same direction. It means they're a multiple of one another. So if A and B are parallel, we want to find the unknowns here. Now the only common number we're given is the y direction, okay? So we can see A has a y direction of 3, and given B is parallel to it, it means it has the same direction, and we can see that this is double the size. So what that means is if we have this relationship, A is equal to 2 times B. All right? We know their direction's the same. The only difference is B is larger. Okay, B has a larger magnitude. And so given that, we can determine the value of x and z. So x is going to be, so A to B, the other way we can understand the relationship is like this. B is equal to half of A. I've stated those around the wrong way, haven't I? Sorry. B to A, 2 lots of A, 2 times 3 will equal B. 2 times 3 will equal B, which means A equals half. Sorry about that. Right, 2 times 3 equals 6, 2 lots of A equals B. Alright, so that means the value of x is going to be 4. Alright, because it's 2 times this one. The value of B is 2 times A. So we've got x is 4. And z here, well, the value of A is half of B, so the value of z is half of minus 5 on 2. And so then we'll just state the vectors. We'll have A is 2, 3, minus 5 on 2. And we'll have vector B is 4, 6, and minus 5. Alright, sorry about that issue there. Okay, so that's the first question. Alright, in the second one we've got 2 coordinates. We've got A, 0, 1, 3, B, 2, 4, minus 1. Part A, find vector AB. So the vector from A to B is the coordinates of B, take away the coordinates of A. So 2 take 0, 4 take 1, and minus 1 take 3. There is vector AB. That's our answer to part A. Okay, part B says find the unit vector in direction AB. So we've got a formula here. A unit vector just means a vector that's 1 unit long in the direction of AB. And so the way we're going to work this out is it's 1 on top of the modulus of AB multiplied by vector AB. Alright, that's the formula for a unit vector in the direction of AB. And so we'll just evaluate that. It's going to be 1 on top of the square root of 2 squared plus 3 squared plus 4 squared in this direction. That gives us, that's going to be 4, 20, 29, square root of 29. That'll be our answer to part B. Okay. Part C says, find the vector V given it is in the direction of AB but 5 units long. Alright, so what we've done in part B here is we've found that this is a vector that is 1 unit long in the direction AB. So if we want a vector that's 5 units long, we're going to just multiply 5 multiplied by the unit vector in the direction of AB. Alright, so this is the 1 unit in the direction of AB, but we want it to be 5 units long, so we just multiply the unit vector by 5, and we'll just simplify that. 10 on root 29, 15 on root 29, and minus 20 on root 29. Alright. Part 1 here. It's ABC. Okay, part D. Find the coordinates of C given C divides AB in the ratio 2 to 1. So here's point A, here's point B, and C divides it in the ratio 2 to 1. All right, divides A to B in the ratio 2 parts to 1 part. That's 2 parts, that's 1 part, that's the coordinates of C. Okay, so what this means is we can see vector AC is 2/3 of vector AB. All right, the vector from A to C is 2 out of 3 parts of the way from A to B. So let's work out vector AC. 2, 3, and minus 4. And we'll simplify this. That's going to give us 4 on 3, 2, and minus 8 on 3. Now we want the coordinates of C. So that means we're going to go, all right, what about vector OC? Vector OC is equal to vector OA plus vector AC. All right, so we've worked out vector AC here. It's this one, 4 on 3, 2, and minus 8 on 3. And vector OA is just the coordinates of A expressed as a vector. So that's 0, 1, 3. We add those two vectors together. 4 on 3, 1 plus 2 is 3. And 3, take 8 on 3 is positive a third. So we've found vector OC, which means the coordinates of C are these ones here. All right. Cool.